Welcome, this is Tutor PVS. Then this is an organic chemistry question. This question is about alkanes and alkenes. Butane belongs to the alkene homologous series. Don't worry about the one, I'll explain what that means. This just means that the double bond is positioned on the first carbon atom. All right. Members of the same homologous series differ from one member to the next by a CH2 group, and they have similar chemical properties. State two other characteristics of a homologous series. Now, in this case, they haven't specified which one, so they're talking about I don't know how many there are, but there's alkanes, alkanos, carboxylic acid, and so forth. These, they are all called homologous series, and they have got characteristics that are applied to any homologous series, apart from them differing by this and having similar chemical property. So apart from those two properties, one other property is that they have the same functional group. They have the same functional group. Another one is they don't have the same chemical properties, but they have, I would say, they have a trend in the chemical properties, or they have different chemical properties. Physical. They have different physical properties, in which we call it's a trend. Another one we can put is that they have the same general formula. The same general formula. For example, all alkenes, you are going to find that they have got this. All right? All alkenes, all right, you are going to find this. So that's a general formula we're talking about. Figure 4.1 shows the display of butene, and you can see that the carbon, the double bond is on carbon number 1, like that. We label number 1, 2, 3, and 4, like that. Explain how figure 4.1 shows that butane or but1 or butene, just call it like that, is unsaturated. Unsaturation means the presence of a double bond. All right. Another one is that we can see that not all carbon to carbon bonds are single. So I will give this. All right. So there is a double bond. There's a double bond between carbon to carbon bond. Or you can say not all carbon to carbon bonds are single. Whichever you're comfortable with, move on. So the presence of this double bond, you can see that this one is not bonded to any hydrogen atom. Like, it is bonded, but not completely. Let's say they are supposed to be like that. But we know that carbon can only form 4 bonds. And this carbon here, it has already formed 1, 2, and there are 2 here, so 4. Same thing applies to this one, it has got all 4. So they are not fully bonded. Also, they are not single. Not all of them are single. Give the structural formula of butene. Structural formula. So you can say there are 2 carbon. So there's the first carbon atom. So you write it, first carbon atom. It has got how many hydrogen atoms? 3. So it has got 3 hydrogen atoms. The second carbon atom, okay, it has got how many hydrogen? 2. That's how we call it. The third carbon atom, it has got 1 hydrogen. You write it like that. Then there's a double bond. You put it like that. Then we have a fourth carbon atom having 2 hydrogen atoms. That's a structural formula. There's a difference between a structural formula and a chemical formula. I hope you get the concept now. Draw the displayed formula of an isomer. Now, an isomer is a compound that has the same chemical formula as the other compound, but they differ in their display formula. Get the concept right? So, how can we write an alternative form of this? Well, here's the thing. You can just shift the double bond anywhere here. You can bring it there, you can bring it there. It's up to you. For example, I can have a situation where I've got this carbon atom, this carbon, I bring the double bond there, then I keep like that. Okay? I have like that, like that, like that. You can see that I'm still having the same hydrogen atoms. I'm still having the same 1, 2, 3, 4, 5, 6, 7, 8. I'm still having 8. 1, 2, 3, 4, 5, 6, 7. Where is the other one? Here. 8. What about the other one? Can you think of another one? Yes, there can be. Here's the thing. What if I bring all the single carbon atoms there, singly bonded, then I do this. I do this. If I do, I also do that. Then I bring the double bond here. It is still the same because this carbon atom has got still 4 bonds to it. 4 bonds to it. Then I can do this. Still, this one has got 4. This is still an isomer. You see, right? So yeah, I hope you enjoyed this video, and please subscribe and follow for more. Okay.